Welcome to another video by Pharaoh's Technology. Today we're going to talk about error trapping in your VBA code. Frankly, you could test your VBA code to your heart's content, but you still won't find every possible bug until you deploy it and let the user start working with it. And so you have to be able then to handle errors gracefully. In fact, if you don't, this is what you end up with. So here we have some code, and here we have an obvious error, but no error handling at all. The lack of error handling would then result in just this dialog box. That dialog box basically says, oh, I'm sorry, we quit. So what you've got to do then is you've got to find ways to elegantly trap your error codes so that you can debug them, so that you can get the information needed in order to fix the problem. Let's go ahead and see what an error trap would look like. Because the minute you have an error come up, it's called raising an error. The minute that happens, you end up being able to trap that error with an error handler. It goes then, once the error happens at the x equals 1 divided by 0, that error is raised. So immediately what happens in the VBA engine is that it looks for an on-error command. Well, on-error then executes and it says go to error handler, which is a label. So we're going to go down to error handler, or ERR handler. Then the next part is the code that we want run when the error is hit. So we're going to then say, okay, we got a message box. We expect a return from the message box, so we got to trap that. It's going to be a long integer because we're expecting a yes or no. And so this is the one, do you want to inspect the error? If we say yes, then of course it goes down and stops, and we can examine the error in the immediate window. We can kind of look to figure out what might have been wrong with the code. Upon inspections, we may find the code. It might take more research than that if it's more complex. The next thing that happens is it goes to this resume command. The resume command then can say resume, just go, or it can have a command afterwards that is a label. Now, in this case, we've decided to put a label after the resume command, which tells it then to go on up to ERR exit, which is another label, okay? And then the next command right after it is to exit the subroutine. So here you say, do you want to inspect the error? If we say yes, code stops. Now, when you inspect the variable down below, you find out the variable is 0. And, that's obviously not what we want. So we then resume, and then it says, do you want to inspect the error? Because resume starts over. And when we say no, it says division by 0, which is just the error description. The pathway is set by your code where you determine what's going to happen next, rather than just letting VBA spit out a generic error code to the user. What happens when the error is hit is an ERR object is created. The ERR object has several different methods after it: an ERR number, description, source, help file. I've put here examples of what we could see if we looked at the ERR data at the time of execution in that last application that we just ran. So the error number is 11 and the description is division by 0. Those are the two obviously most used messages that we can give to the user. The source, called debugging, is the project that we have in the VBA code. The help file actually is on most users' desktop. It has all the documentation for each of the error numbers. So we could actually send them to the help file to give more information as well. Sometimes you actually need to ignore the error. Sometimes you have a situation where it just doesn't matter if there's an error in the particular piece of code. And I'm going to show you an example. Now, it's a little bit dangerous to do this, and the command is on error, resume next. In other words, what it's saying is, if there's an error here, just go to the next command. Yeah, it's a little dangerous if you don't reset the error code that says to move on, and that is with on error, go to 0. Now, go to 0 resets the error code back to normal. So let's see an example of how we might actually use this to our benefit. Here we have some code. And what we're going to do is we're going to create a collection. And the collection can't have any duplicates, okay? And we're going to set an array together called VA fruit. And then we're going to loop through that array and put these items in the collection. So for I equals the lower bound to the upper bound for VA fruit. Notice right in that loop, we have on error, resume next. In other words, ignore the error. And we're going to add to column unique dot add VA fruit, okay? In other words, we're only going to add the data that was given to us in the array. Forget about the error message that is created by the fact that we have pair duplicated in our data, and we will just move forward. And then after moving forward, we have a debug.print to see what it looks like in the immediate window to see if it actually worked. Okay, so let's see. Did it actually work? We've got apple, pear, orange, and grape. We got rid of both apple and pear duplicates and output only the 4 unique items, apple, pear, orange, and grape. So what we did in this video is to make sure that you understand the idea of how to catch an error trap. Once you capture it, how to write a little bit of code that tells what the program should do in the case of an error, and showed you how to ignore an error as well. Be sure you use that go to 0 in order to make sure you don't keep that error perpetually being ignored all the way through until your program is done executing. That would be disastrous. But if you found something useful in this video, hit that like button, and hope to see you again later. Thank you.